Alright, welcome to lesson 2.2, slope from multiple representations. So today the learning target or the goal of this lesson is to find the slope from different sources such as a table, graph, or ordered pair. Alright, so I've written our learning target. I also added another source here, word problems. Okay. So how do we find the slope from a graph? If you remember from middle school, the slope is rise over run. Okay, so you're actually going to count the rise over the run. If I had to describe the slope of this line, I would say it is going down, or in fancy words, decreasing. Okay, or going down, or a negative slope. Okay, the second question they have there is, what is the slope? Okay, so I have to look for my rise over run. Okay, so if I look here, if I pick any 2 points, doesn't matter which points I pick, I went down 1, that's a negative 1. So down 1 over 1, which is the run. So my slope is negative 1 over 1, which is equal to negative 1. What does the slope of the line represent? Well, in this case, I want to read the description on the axis here. So the x-axis, we have time, and then the y-axis, I have amount of water. So the slope actually represents the amount of water over time, or in this case, hours. So I could also say this as gallons per hour. Okay. Suppose the water was draining at a faster rate. How would this affect the steepness of the line? So if the water was draining faster, it would take less time to drain the water. So if I imagine a line that drained faster, took less time, so let's say it took 2 hours instead of 5 hours, how would I describe this line? Okay, so the line would be steeper. Line would be steeper. Okay, the water would drain faster. So right now, we calculated that the slope or the water is draining at 1 gallons per hour. Okay, so what would happen if the water was draining at a rate of 0.5 gallons an hour? So that would actually be 0.5 is equal to 1/2. So our new slope would be 1/2 gallons per hour. So how would that affect our line? Let me use a different color here. So if so if the slope was 1 over 2, right? My rise over run was 1 over 2. That means that for every, so let's start at 5. That's the amount of water I started. So I would rise 1 and run 2. So fall 1, rise 2. So my line my new line would be a flatter line. So the line would become flatter. Okay, let's look at the intercept. So if you remember, the definition of the intercept is where the line crosses that axis. So the x-intercept is where the line crosses the x-axis, and that's this point. Okay, so it's that point is 5, 0. Okay, let me fix my 5 here. That was not a good 5. Okay, so 5, 0. And my y-intercept is 0, 5 up here. Okay. So what does this represent? So this is 5 hours. So in the context of this problem, okay, it's how long hours it takes to drain the pool. Okay, to drain the pool. And the y-intercept is 5 gallons. And if you notice, that's the most water. So that's the amount of water we started with. And if you remember, another word for y-intercept is the beginning, so the starting point. So there's 2 special cases. Okay, there's the horizontal line, and there's the vertical line. Okay, so if you remember from before, the slope is the rise over run, okay, also known as the delta y over delta x. That's the change in y over the change in x. Okay. So let's look at these 2 special cases. Okay, so the horizontal line, if I was going to calculate my rise over run, okay, if you notice, my rise here, the line from, let's pick any random point. So from this point to this point, my rise is 0. And my run could be anything, right? So I'm just going to put a number here, but it could be anything. Any number, 0 divided by any number is 0. So in our case, when you have a horizontal line, the slope is 0. It's a flat line. Okay? You can think of the steepness being 0, flat. And the equation, okay, if you remember, y equals mx plus b, if my m is 0, zero times anything is 0, so my equation just becomes y equals b, which in this case is 1, 2, 3, 4, 5. So it's just a number, right? In our case is 5, okay? So y equals number. Okay, so let's look at a vertical line. if I want to calculate my delta y over delta x, so let's look at my rise. So my rise from any point, so from this point to this point, it's a number. And my run from here to here, how much did I go left and right? Well, that's 0. Okay. However, any number in math, you cannot divide by nothing. Okay. I can't give a Snicker bar to 1 to 0 people, right? I can give it to 1 person. Okay, so you can't divide something by 0. We call that undefined. So the slope, okay, is undefined. You cannot divide by 0. Okay. So in that case, the equation of this line ends up being the x-intercept. Okay, so x equals a number. Okay, and this number is the x-intercept, where the line crosses the x-axis. Okay, this number here is the y-intercept. Okay, so in our case, it was 5 up here. And in this case, it's going to be x. The equation of the line, okay, is x equals 4. Where can I put that? So, okay, so in math, you can't divide by 0. It's called undefined. Okay. And we talked about how the equation of this line is going to be x equals a number. And so in this case, the equation is x equals 4. Okay. And in this case, as we already wrote it here, this line is y equals 5. Okay. So this spells out Hoy, and this spells out Vux. Okay, so that's something we want you to remember. Hoy and Vux. So if it's a horizontal line, you will know that the slope is 0 and that the equation is y equals a number. If it is Vux, or a vertical line, then you know that the slope is undefined and x equals a number. And in this case, x equals 4. Okay, so let's flip the page. So slope from a table. How do we find the slope from a table? Okay, so now we're going to utilize our change in y and change in x. So if I look at this table, my x's are changing by 1, and it's going up, so I'm going to put a plus 1. And my y's are changing by 2. Okay, and it's going up, so I'm also going to be a plus. Okay, so all right, so my delta y over delta x is this number. The y goes on top, right? Y over x. So I have it as 2 over 1, or just 2. That is the constant rate, or slope as we call it. Okay. Okay, so something we didn't talk about. Oh, yes. So this is from Unit 1, if you remember it, sequences. Okay. So in order for a line to be linear, you need to have a constant rate of change. So constant rate of change, okay, means it is a line, okay, or it is a linear function. So this change is always the same, meaning constant. Constant means the same. Okay. So this change doesn't change, it is the same. So we're going to say, yes, it is a linear function. Okay. Our domain, as we already learned, is the x values. and then my range is the y values. Okay. Alright, so I will let you do this second problem, and then you can check the answer. So you can pause the video and then get the answers. Alright, so when I look at the rate of change, my x's are changing by 3, going up. My y's, the first y is going down by -4, then -7, then -8. So this is not the same. Okay, so I cannot say that my rate, my y over x, is not constant. Okay, my rate of change is not constant. Okay, so that means I don't have a linear function. However, I can still list my domain and range, so I went ahead and copied the x and y values. Alright, slopes from coordinates, or also known as ordered pairs. Okay, another name for coordinates. Okay, we are going to utilize this formula. Very important. Okay, you don't have to worry about memorizing it because it will be on your star sheet. Okay, this ordered pair down here should be over here. Okay. Okay, so there's two ways of doing this, so I'm going to use the formula here. Okay, so if I was looking at these 2 points and I apply the formula, okay, I would pick, this is my x2, y2, and this is my x1, y1. So if I plugged it in, I would have 3 minus 4 over my x2, 5, minus my x1, which is 2. So -1 over 3. Okay. Now I have to test this next pair. So 5, 3, 8, 2. Okay, so let's see what that gives us. So I got my y2, x2, y1, x1. Okay, so I get 2 minus 3 over 8 minus 5, which also gives me -1 over 3. Okay, so if you notice, these are constant. It's a constant rate of change. So let's check 8, 2 and 11, 1. So if I subtract the y's, I have 1 minus 2 over 11 minus 8. And that also gives me -1 over 3. Okay, so the constant is change. The rate is constant. I'm sorry, the rate is constant. So, no, actually here I should answer, what is the constant rate of change? So here the constant rate of change is -1 over 3. So that means it is a linear function. The domain are the x values, so I'm going to put 2, 5, 8, 11. And my range are the y values, 4, 3, 2, 1. Alright. I want to show you an easier way of doing this, that I think it's easier. Okay. So you could also put this as a table. So I'm going to copy the x values, so 2, 5, 8, 11. I'm going to copy my y values, so 4, 3, 2, 1. And then I'm going to look at the change. So my x is changing by 3 every time. And my y is decreasing by 1. Okay, so if I put my delta y over delta x, okay, or the slope, that is -1 over 3. Okay, so 2 ways of doing the same thing. So now I'm going to give you some time to do the second problem. So go ahead and do that. Okay, hopefully you found the rate to be -3/2. If you check every single point, you'll see you get the same rate, so it is a linear function. And then here's the domain and range. So copy that down. And if you need to, pause the video to copy the rest. All right, last page. Okay, constant rate of change. Okay. Slope. That's another name for slope. So what are some words in a word problem that can give us a hint that that value is the slope, right? So if I read this first problem, we have Andre enters a jalapeno eating contest. Andre eats them at a rate of 7 per minute. Well, here really we have two clues. Okay, so rate, the word rate or the word per, okay, can be a hint that the slope, that is the value of the slope. So, all right, so he eats 7 jalapenos a minute. When the contest begins, his plate has 60 jalapenos on it. So, when the contest begins, right, he has 60 jalapenos. So, begins, starting with, right, started with, okay, so this is your initial value, your y-intercept, okay. Remember the letter here is m, this letter is b on our y equals mx plus b equation. Okay, so he eats them at a rate of 7 per minute, so the slope is 7. Okay, if you want to put over 1. So he eats 7 jalapenos every minute. That's pretty fast. The initial value, he started with 60 jalapenos in his plate. How long will it take to eat all 60 jalapenos? Okay, so they're asking me, there's multiple ways of doing this, right? You could do it the common sense way. He started with 60. Every minute he loses 7, so you could count down by 7 from 60. So I could say, 60, then 53, then 46, and so on. But that would take me too long, and I might not end up with 0, the exact value. Okay, so let's look at how to do that with an equation. So y equals mx plus b. So I know my rate of change and I know my beginning. So I have y equals 7x plus 60. Okay. And they want to know how long will it take for my jalapenos, my y, to be 0. So if I plug in 0 and solve for, okay, so let me back up a little bit. Okay, he's eating 7 jalapenos a minute, which means you have 7 less jalapenos every minute. So our slope is actually a negative. Okay. Alright, so to solve this, I have to subtract 60 from both sides. So we get negative 7x equals negative 60. And my next step is to divide both sides by a negative 7. So my x, okay, is 8.57 minutes. This is my answer, okay, 8.57. Ian is going to the Cove volleyball game. He buys a ticket for $2.50 and decides to buy several hamburgers that cost $7.50 each. Okay, so $7.50 each, or you can say $7.50 per hamburger. Okay, so this is another clue for slope, the word each. Okay. There's also a one-time fee here. Okay, this is, he buys one ticket for $2.50. He doesn't have to buy any more tickets than that. Okay. So you can say that the cost is $7.50 per hamburger plus the $2.50 for the ticket. Okay. So if you notice, this is also in the format y equals mx plus b. Okay. Where x here is equal to number of hamburgers. Okay, so let's see what these statements say. The slope represents the cost per food item. Okay, that's true. The slope represents Joe total cost. Okay, that's not true. That's the cost per hamburger. The slope represents how many items of food he can buy. I don't think so. And then the slope represents the cost of the ticket. So we know the ticket is $2.50, so that cannot be true. So the answer is A. Example 5. Which of the following statements about the slope is true? Okay, so if you remember, mx plus b, m is the slope. So here's my slope. Okay. I want you to write down the definition of slope, which is change in y over change in x. Okay. So what does that mean? So this means every time, okay, or rise over run. Let's use a rise over run. Every time my y goes down by 5, my x will go up by 3, right? Will go up by 3. When there's no sign, you assume it's positive. Okay, so let's read the statements. Or let's look for the statement that reflects this. So I'm looking for decrease by 5.
Attention to anybody.
Alright, so here we go again. So we're looking for something that says going down by 5, going up by 3. So if you look carefully there, B says increase by 3 and decrease by 5. So this is what we want. Okay. Alright, that's it for the notes. If you have any questions, make sure to take advantage of the tutoring. So once again, thanks for watching this, and I'll see you next time.